Okay, hello everyone. Welcome to YourPedia education. So, चलो start करते हैं live session. So basically, as I'm getting the feedback from the student that paper was tough, right? Am I right or not? Yeah, basically, if the paper is tough, that is for everyone, not only for you, right? If your paper is tough, then your cutoff is going to be down, right? It is not going to be 90 and something like that. It will be come out to be 50% if the paper is tough. So because that this paper is for all of you, right? All of the student prepare like we are taking the feedback from past exams. Now they change the pattern. If they change the pattern, then automatically your cutoff is going to be low. So basically you can get an idea from this thing also that I'm getting only 10 to 12 questions from students, right, that means the paper was actually tough for everyone. I asked to every students and they send me only 10 to 12 questions. This is that, sir, we only remember these things, right? Okay, Nikhil says that paper is easy. Yeah, it will depend on your preparation, right? If your preparation is good, then it will be easy for you, but I'm saying in general that paper is tough, not easy. Yes, right, Ajay Kumar. Most of the student don't know the question याद ही नहीं है स्टूडेंट के, इतना लेंथी पेपर था, कहते हम अटेम्प्ट ही नहीं कर पा रहे हैं सारे पेपर को. 60 क्वेश्चन तक अटेम्प्ट किया मोस्टली ने, 60 50 लाइक दैट, राइट. अच्छा, जाने ही नहीं दे पाए. हार्डर देन द गेट इफ यू ऑल्सो माइंड टाइम. हाँ, ये बात हो सकती है कि गेट के एग्जाम से ये हार्ड एग्जाम हो सकता है, क्योंकि दो चीजें थी. एक तो टाइम यहाँ पे कम है, क्योंकि गेट के एग्जाम में आपके पास 65 क्वेश्चंस होते हैं. फॉर दैट 65 क्वेश्चन यू आर हैविंग थ्री आवर्स, बट यू आर हैविंग 2 आवर्स हियर एंड विदाउट द कैलकुलेटर, राइट. द एग्जाम इज रियली टफ. इलेक्ट्रिकल का कैसा था भाई? इलेक्ट्रिकल का भी मेरे को भी आइडिया नहीं, क्योंकि इलेक्ट्रिकल के क्वेश्चंस नहीं आए, बट इलेक्ट्रॉनिक्स के क्वेश्चन जो मेरे पास आए हैं तो मोस्टली कैलकुलेटिव पार्ट था. कुछ बच्चे ये कह रहे हैं कि क्वेश्चंस रिपीट भी हुए हैं, राइट? एम आई राइट? द क्वेश्चंस वाज रिपीटेड इन द एग्जाम. इलेक्ट्रिकल भी अच्छा लेवल का था काफी. ओके, इलेक्ट्रिकल का भी अच्छे लेवल का था. तरुण सेज दैट इलेक्ट्रिकल एग्जाम is also a good level, right? ESC level. Yeah, question repeat, right. Yes, 2 to 3 questions were repeated there, right? One question is from Superheterodyne receiver that was repeated. Am I right? Okay, so one more thing, if you remember the question, you can put that question in the chat, right? If you remember the question. So basically, don't lose the hope that you can't crack that. Why was the control where we have to find the early angle? We were have to calculate the angle which cannot be calculated without calculator. Yeah, that's the main thing. That's the main thing. Without the calculator, how you can do that thing? So basically, there will be a part that is called approximations. When you go without the calculator, he put the option like that. The option is differ with the big numbers, so that you will approximate that thing. Right. Ajay Kumar says that, see the above message. I'm not getting any exact question. I see your message. Right, Ajay? I'm not getting even a single question from there. You just write the statement that this question is from there, this question is from there, right? You can write if you get the yes. If you are having the exact question, you can write that. Then only I can answer for that one, right? Yeah, the calculations are lengthy. Right. Calculation are lengthy. That's the correct thing. Yes. Okay, let's start what we have. The first question, what I have here, that the superheterodyne receiver has RF section that is used for selecting desired station. Is it correct question or some change in that one? In superheterodyne, RF section is used for selecting desired station. Right? Is it correct? Or something you change that one? So basically, the RF section in superheterodyne receiver is generally used for what purpose? Generally used for image rejection. To reject the image station, we are using that RF section, because when you tune your local oscillator, you change the frequency of local oscillator, though your LO frequency will change, so that we can reject, yeah, image rejection. That is the correct answer, right. Okay, that is for image rejection. Superheterodyne, the answer should be for image rejection. If you have the option, because I don't have the option, right? I don't have the option. So basically the answer is for image rejection. It will be used for image rejection. So in the options, if you see the image rejection, that is the main purpose, right? But it is also used for amplification purpose. It is amplify the desired station and de-amplify the lower station. There is no such option. What was the option, Harshit, if you remember? Harsh, not Harshit, Harsh. But the question was the superheterodyne choose the best. Four resistance of equal R each on a square, right? And one R in one between the opposite node. So find the equivalent. See, Subham Kumar, so we have to find the equivalent. We should know that at which terminal he is asking. Subham Kumar says that we are having four resistance like in the form of square here, and we are having a resistance here like this, and we have to find the equivalent resistance, right? R is here, 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 like that. If he is asking from this part, yeah, at between these two terminals, A and B, what you can do? R in series, R in series, then when they will go into the parallel, that is going to be when you are having two R, because this is R in series, this is R in series, that is going to be how much? R. And RR series, that is going to be how much? 2R. So this is 2R, this is 2R. So 2R and 2R are in parallel when you are having equal resistance. Okay, adjacent terminal like here. Okay, okay. Okay, here you have to calculate from here, right? A and B. Adjacent terminal. Is it correct now? Yes. Okay. So basically, when you are going for this one, this R in series, that is going to be 2R, right? 2R and this R is going to be in parallel. So how much is that? 2R into R divided by 2R plus R. That is going to be how much? 2 by 3R. Now, 2 by 3R is the equivalent of these three resistance. Now, now this one will going to be series with this one. So now we are having 2 by 3R plus R, that is going to be 5R by 3 up to here. Now 5R by 3 is in parallel with this R. 5R by 3, and when you remove this one, when you remove all of these resistance, now we are having a single resistance in place of that one, that is 5R by 3. This 5R by 3 and R is going to be in parallel, right? In going to be parallel. So that will be 5R by 3 into R divided by 5R by 3 plus R, right? So that's going to be 5R by 3 R divided by 8R by 3. So this 3 cancel out, 1 R cancel out. So answer is 5 by 8 R. That's the correct answer for this question. 5 by 8 R. Arjun, that is not R by 2. Answer is 5R by 8. 5R by 8 is the correct answer for this question. Okay, Subham says, sir, I have attempt 20 in FT section and 35 in core. What should be the cutoff? I have not attempted questions on which I had no confidence. Yeah, you have the good chance. If you are attempting 35, 20, around 55 to 60, if you are scoring 55 to 60, 60 above, maybe we expect the cutoff this time because he changed the pattern and most of the questions are lengthy in that exam, right? Question on H parameter from analog electronics. What was that? Bionic, what was that question on H parameter? Ajay Kumar says reasoning is easy. Okay. This time was messed up. They had given maths also. Okay. In mathematics, what are the questions? Do you remember? That not mathematics, profit loss, that is the aptitude part, right? That is the aptitude part. Okay, next question what I have, where EF, where EF, EF means the Fermi level, the Fermi level of N-type semiconductor, where the EF or N-type semiconductor will change by increasing the doping. Okay, they are asking that how your EF means Fermi energy level will change according to the doping. Right? If EF is changed as you increase the doping of N-type semiconductor, so in N-type semiconductor, right? What you are seeing, this is EI here, this is EV, this is EC conduction band, and this is your EI. EI means intrinsic Fermi level. So basically, your the Fermi level of N-type semiconductor EFN is lying just above this EI, right? Close to the conduction band. As you increase the concentration of electron or you increase the doping, that will be shifted towards the conduction band, close to conduction band, right? Correct. The answer for this question is close to conduction band. This is moving towards or close to conduction band. If that is having an option, that means that is correct. Close to conduction band. Yes, I got that point, Sandeep. That this superheterodyne question is repeated, right? Close to conduction band. I think is mostly student give the correct answer for this question. This is the easy question, you can say. Calculate the entropy of P0, P1 is equals to 0.5. It is already P0 and P1 is given to you 0.5, probability of 0 and probability of 1 is given to you 0.5. Then he is asking that how much is the entropy. Someone write that question. uh, Usman, write that question, that calculate the entropy of P of 0 equals to P of 1 is equals to 0.5. So if you go for, this is an equiprobable signal. Whenever you are having a equiprobable signal, then that entropy is equals to number of symbols, right? So basically, if you directly write that formula, that is 1 by 2 log 2 base the probability 1 upon probability, that is 1 by, sorry, log 2 base 1 upon 1 by 2 plus 1 by 2 log 2 base 1 upon 1 by 2, right? So that's going to be, this value is going to be 1, this value is going to be 1. So 1 by 2 plus 1 by 2, that is going to be 1. So the entropy is 1 bit per symbol, right? In that entropy question, is entropy is calculating using natural log. No, natural log, if you calculate, I already discussed that thing, that if you calculate with natural log, its unit is different. That should be on the base 2, right? That should be on base 2. Suresh, sorry, Sai, that entropy unit will change. It will depend on the question what is given to you, that and unit is given to you, what was that. It will depend on that. Uh, if I talk about the overall paper is hard, not easy. This is calculative. I can't say that this is hard. This is calculative part, right? Most of the questions are calculative. That will time consuming. You can say without the calculator. That will take times. So in that type of paper, you have to choose wisely that which question you have to use solve or which you have to left. Okay, if SNR in quadrupled and the bandwidth is okay, SNR is 4th times and the bandwidth is constant, what happened to capacity? Okay, he's talking about the C capacity is equals to B log 2 base 1 plus SNR, right? Bandwidth is constant, then what about the, if you are increasing the SNR, the channel capacity will also increase. Graph question on series RLC circuit. Okay, channel capacity theorem. That, I think this is the question from channel capacity theorem. He says that you have to do the SNR 4 times, right? You have to do the SNR 4 times, and bandwidth is constant. Sir, I have attempt 85 in that. I think I will go to 60 to 75, and general category. Yeah, you are having the chance, I, to get that one, right? 65 to 75 marks if you are getting, that is a very good score. Basically in this calculative exam, right? Not, you can say, cannot say that is topper, but yeah, he's in very good position, right, Sai? If you attempt that much amount of questions, 85, and you are getting 65 to 75 marks, that is, you are having very good chance, right? So this is the question. When you 4 times the SNR, then means your channel capacity will increase. Okay, next, Usman says that in PCM, if quantization level is 256, the number of samples is 8. Usman, what is that one? I didn't get your question. Can you type the complete question again? Okay, statement. So, okay, PCM, if quantization level are 256, number of samples, that is not number of samples, that should be number of bits. The number of bits are 8. Yeah, 2 raised to power 8 is going to be 256. So that is correct. And quantization is followed by encoder. Both the statements are correct, Usman. That in PCM, if quantization level is 256, then the number of bits are 8, and quantization is followed by encoder. That is the correct one, right? Bionic says that control system question, a unity feedback system transfer function is 5 by 6, and the system, while drawing the signal flow, forgot the feedback. What will be the calculating the transfer function as? So basically that is a unity feedback system, right, Bionic? Unity feedback system transfer function is given to you 5 by 6, so that will be g upon 1 plus g. From that one you can easily calculate the z by just multiplication. Cz is equals to 5 plus 5g, that's going to be g is equals to 5. So it means if you are having only open loop system, right, you forgot to apply the feedback, the gain should be 5, right, Bionic? Understood? This is the correct question or not? Check, everyone, if you remember. And third statement, Usman says the third statement that PCM is depend on temperature. No, PCM is not depend on temperature. Yes, Subham Kumar, we will discuss that one later on. No, answer is 11 by 6. MK, how? If he is asking that exact question, if you are having open loop system without the feedback, then that should be equals to G. Ring counter is 0010 sometime something. Anyone remember a ring counter question? रेशो बोला था सर. ओके अजय कुमार, रेशो बोला था. ओके. So answer for that question in series RC circuit, if IP is unit impulse, then output across capacitor is. Sai, what was the option? Do you remember that? After 3 left shift. Okay, it means the most of the question are calculative. That's not a one-liner paper, right? 3 shift to left. That's easy. If you are having a ring counter, in ring counter, the value which will be going inside that one, right? Like this. If you are having a ring counter, 4-bit ring counter, and it is having 1000, so if you shift it towards the right or left, what was that? Ring counter left shift 3 times for 010. Okay, 010, right? 010. So that will be going like this. This will be going like this. So it will be changing like this. You can go for that one. Choose E power minute t by RC. Yes, sir, I have chosen E. Power. So there are 5 options or only 3 options? Oh, sorry, 4 options. Yes, yes. मेरे को लगता है मोस्टली हुआ क्या है, क्योंकि टीसीएस वाले ही गेट के एग्जाम के लिए प्रिपेयर वो कराते हो, मतलब एग्जाम कराते हैं, तो उन्होंने गेट लेवल का उठा के डाल दिया 4 ऑप्शंस. देन हाउ सा यू चूज द ई ऑप्शन? e power minus t. Okay, e to the power minus t by RC. Okay, okay. Dilip says y is equals to 3 times x1t plus x2t. Transform r x1z, x2z, yz is. Uh, I didn't get Dilip your question. Yes, paper is good. Level is good. We have RC network, time shift delta is input. Now the output. Here you can directly say that it will be e raised to the power minus t upon RC. Right, Usman? That will be e raised to the power minus t upon RC. The maximum power transfer when RL and with no source and voltage source and current source was given. See, basically in these type of questions, in this type of paper, what should you do? First, you have to check all the paper and only you have to do the first one-liner questions. What was the one-liner? If you're stuck in the big question, that will be the problem. Sir, first tell the question you have collect, right? Sir, please, we are not getting the questions. Okay. So I have the first question, that is superheterodyne receiver. The second question which I have, that is for this n type. The third question which I have, let's discuss that. I think it is not correct or not. Calculate E dot ds for a hollow sphere having radius a to b. Depletion capacitance, anyone remember? Yeah, this is the question. I think it will be E dot ds is equals to what when you are having a hollow sphere of a radius a to b. Something like that. I don't have the correct question, but this is the question which I am getting from the student. Do you remember any modification in this one? Yes. Anyone? Remember this question? Okay, he says find E dot ds at the center. The question is from the diffusion capacitance, that how was paper level? Paper level is, you can say, difficult as it is calculative, right? So I don't know where he says that you have to find E dot ds. E dot ds only or integration of E dot ds? Find E dot ds at center. At center it will be 0. Right, Usman? At center it will be 0 if it is asking about at center. Integration is there. Okay, basically if you remember, that is a Gauss law. E dot ds is going to be how much? If it is closed integration here, that will be q and close divided by epsilon. If you go at center, because it is yes, yes. If it is a hollow sphere and inside that one no charge, so it means that only charge exists between a and b. So that means that value is going to be 0. Answer will be 0. Yes, I understood that thing by Pionix, that the questions are hard to remember. That are hard to remember. Yes, one more thing. You can get an idea because I asked many students and I'm having only 10 questions. Seven or 8 questions, you can say, not only 10. Next is, it is given to you that rho v is equals to rho naught 1 minus r upon r, and r is going from 0 to capital R, then he is asking the total charge inside this sphere. He is asking total charge inside the sphere. Is that question is correct or not? Tell me. I'm getting that one from the students. Yes, is it correct? So basically in that question, what you have to do, you have to do the volume integration of rho v dv. It means this will be triple integration. Your r value is varying 0 to r, 0 to 2 pi is the phi value, and 0 to pi is the theta value, right? So it means it is going to be rho naught 1 minus r by capital R square sine theta dr d theta d phi, right? And when you integrate with respect to theta and phi, when you integrate with respect to theta and phi, that is going to be 4 pi, and it is rho naught as it is. So we are having integration 0 to r, that value is going to be 1 minus r upon r into r square dr. So is going to be 4 pi rho naught, and this value is going to be r cube by 3 first. So capital R cube by 3 minus r to the power 4. So that is going to be r cube by 4, the second value. So this is 4 pi rho naught, and this is going to be r cube by 12. So that is cancel it, this is 3. So if the charge is pi by 3 rho naught r cube. So you solved 98 question. That's very good questions. Yes, I cutoff is going to be around 65 or 70. We I expect that thing, that 50-55%, that will be the cutoff this time because paper is lengthy. The impulse response h of t, right? Dilip says, this is the question. Check first, check this one. Let's move to the next one. Right, that's a very good amount of question if you attempt that amount of question. Saurabh. Yeah, that will be going to marks to all, Subham, right? If the questions options are repeating and there is a printing mistake and like that, that questions, if you challenge that, most of the students will challenge that question, and they will give you the marks to all, right? So this is the question which I am getting. Is it correct from the UMFT? The charge inside the sphere. Right. Okay. The next question which I have. Okay, let me discuss the question. Then the Z. This is Usma. The question is what you are having xt is equals to x1t and minus 3xt. Then the Z transform will be. I think this is not a correct question. You don't remember the exact wording for that one, right? Usma. Usma says that h of s is given to you, that is s plus 3 upon s plus 6 s plus 9. Yeah, this is the easy question. He asked that pole and zeros of this system. Pole and zeros of this system. So if he is asking poles are at s is equals to minus 6 and minus sign, and zeros at s equals to minus 3. So these are the pole and zeros of this system. No, basically, Sai, the TCS will not prepare the paper. Paper will be prepared by a team, right? That will be decided by BEL, which will pick up the question, make the paper, and finalize the paper. The TCS is generally TCS is only the, you can say the only the you can say the means company which will take that exam, right? They are not preparing the paper for that one. It's just a joke which I give you, that that TCS is taking the gate exam also, and they will put the same level of question. What can be the cutoff? Yeah, basically the cutoff is going to be low this time. It's going to be around 65, 60, around 70 you can say. पेपर यार, पेपर में टफ नहीं कह सकता, राइट? पेपर को आप टफ नहीं बोल सकते, कैलकुलेटिव बोल सकते हैं, कैलकुलेटिव बोल सकते हैं। टफ पेपर तो वो होता है यार जो आपने कभी पढ़ा ही ना हो और वैसे चीजें वो डाल दे, राइट? पेपर को आप ये नहीं बोल सकते ना कि भाई मतलब बहुत आपका हार्ड पेपर है। हार्ड पेपर वो होता है कि जो आपने कभी पढ़ा ही ना हो, राइट? आपने जो चीजें नहीं पढ़ी हो, हाँ कैलकुलेटिव आप इसको बोल सकते हो। मोस्टली पेपर जो है वो कैलकुलेटिव था। हिमांशु सेज दैट पेपर इज टफ आया था। हाँ पेपर यार, टफ आने का मतलब क्या है? टफ आने का है कैलकुलेशन। कैलकुलेटिव को ही टफ हार्ड बोलते हैं। दैट्स द डेफिनेशन फॉर एवरीवन इज डिफरेंट फॉर दिस वन, राइट? प्रियंका सेज एवरेज अटेम्प्ट 60 65 है बस। हाँ इतना ही मोस्टली स्टूडेंट्स ने किया है जिसने भी अटेम्प्ट किया है। अगर आपने 70 क्वेश्चन, 65 और 60 क्वेश्चन आपने इजीली अटेम्प्ट किए, मतलब एक्यूरेसी के साथ अटेम्प्ट किए हैं, तो आपके चांसेस हैं सिलेक्ट होने के, राइट? ओके। Usman says that is x1 and x2 here, right? X2 here. If you take its z transform, so how you can say it's z transform, not xt? This should be xn. If you are going for z transform, that should be xn here, right? X of z is going to be x1z minus 3x2z. That will be the answer because it is based on the linearity property of the z transform. See, you can't predict that thing that BDL also change the pattern, right? BDL can also change the pattern, right? ये क्वेश्चन रिपीट हुआ था, कौन सा क्वेश्चन? अजय सेज दैट चलो सर चलते हैं, आप भी मायूस हो मैं भी मायूस हूँ। देखो मायूस होने की जरूरत नहीं है, अगर आपने 60 to 65 अटेम्प्ट किए हैं, पेपर सबके लिए इक्वल है, ठीक है? Sir, the question is from network. If 5 resistors are used to make a square, yeah, we already discussed this I in the starting. That is 5 r by 8. The answer for that question. Priyanka says that Z transform. This is the Z transform question which I am getting there from the students. Bionics from a network, the Z parameter, the value were given in terms of, ask that I1 and I2. I don't understand the question, Bionic. Phase and ask in terms of phase and ask I1 and I2. I didn't understand the question. Okay. Himanshu says that h of t is equals to sine of h of t is equals to how much? Sine of omega naught t. And he's asking sine of omega naught t, right? That sine of omega naught t, and he is asking that stability of the system. System is stable or unstable? Stability, right? Himanshu is asking about the stability. Right. If he is asking about the stability from the impulse response, how you can calculate the stability? That mode of h of t should be less than infinity. So basically, if you draw the graph of sinusoidal signal like this, and you take the mode of this one, so this lower part will go up, right, like this. It means if you integrate this value, it will give you the infinite value. It will give you the infinite. So that system is unstable. That system is unstable. that system is unstable. Or you can also think that if you are having sine of omega naught t, and if you give the input to this one sine of omega naught t, that will be give you the output t sine of omega naught t, that is unbounded. So that system is unstable, not stable. Right, Himanshu? Okay, next Usmat says the quality factor. अगर सिग्नल फ्लो ग्राफ में फीडबैक पाथ नहीं होगा तो ब्लॉक रिडक्शन और एसएफजी कैसे होगा? मिस मिशन है फॉर्मूला डेल्टा इक्वल्स टू कब होगा? आई डिडंट गेट योर क्वेश्चन. One option was the sin t question. Give proper input to make it stable. Yeah, that's the correct answer. If it is option, that's the correct answer. If you didn't give this input, the sine of omega naught t, this input you didn't give that system, then for all other input this system is going to be stable. That's why it generally says the marginally stable system, because its poles are lying on the j omega axis, right? सर स्टेटमेंट वाले क्वेश्चन थे बहुत सारे. हाँ, मोस्टली यही मेरे को स्टूडेंट से फीडबैक मिला है कि बहुत सारे क्वेश्चन जो है वो स्टेटमेंट्स वाले डाले हैं. स्टेटमेंट्स वाले का मतलब है उसने ईएससी का पैटर्न इस बार फॉलो किया. ईएससी में क्या पैटर्न होता है? स्टेटमेंट्स दी होती है. वन ऑप्शन वाज स्टेबल इन बिटवीन -1. दैट्स नॉट करेक्ट. एक क्वेश्चन के ऑप्शन गलत थे. हो सकता है भाई गलत हो, वो तो ऑप्शन देख कर क्वेश्चन देख के ही पता चलेगा कि गलत थे या नहीं थे. राइट, यू कांट से दैट थिंग दैट ऑप्शंस आर गलत. चेक क्वालिटी फैक्टर क्वेश्चन अबव. Yeah, I already have that quality factor question. That q is given to you. Q is given to you, that is 10. R is given to you, that is 2000. And omega is given to you 5000. And he is asking L and C. He is asking about the value of L and C, right? Right, Usmat? R is 200. Okay, R is 200. Right. So basically in this question, series RLC circuit is that series RLC circuit, right? Usma, that is series RLC circuit, right? In series RLC circuit, the quality factor is 1 upon R under root of L by C, and omega is going to be 1 upon under root of LC. When you multiply these two quantity, parallel RLC circuit. Okay, in parallel RLC circuit, the quality factor Q is going to be R under root of C by L, the opposite to that one, right? Opposite to that one. If you go for this one, it means if you multiply these two terms together, so Q times omega is going to be how much? This C under root C will cancel out, R by L, right? And from this one, if you calculate the L, that will be R by Q omega. R is how much? 200 divided by 10 into 5000. Right, so this will cancel, a 1 power. So it's going to be 2 by 500. Right, so from here you get the L value. If it is asking that in mini Henry, that will be 2000 divided by 500, that is going to be 4 millihenry. That is 4 millihenry. And similarly, you can replace that L value in any one of the equation and you will calculate the C value. Yeah, this is the lengthy question. It's not like you can see the question and just put the answer for that one. Right? Okay. Next, Himanshu says the Laplace transform of integration of d of dt of xt. He is asking about the Laplace transformation of integration of xt dt. Like this? Or something else? He is talking about the Laplace transform of this quantity, the integration of dx by dt. No, sir. What was that? Because Himanshu says that Laplace transform of integration of d upon dt of xt. If he is asking this, this is not the correct question. It should be something else. Boolean expression for M3, M4, and M's term, M7 in terms of what? Laplace of integral of xt. Okay, Laplace of integral of xt. That will be x of s by s. This is one liner, right? He's talking about the Laplace transform of integration of xt dt. So if you go for Laplace transform of xt dt, that will be 1 upon s into x of s. Right, it's easy. Next thing, the mean term 3, 4, and 7. So summation m 3, 4, 7. We have to write it. We have to write it, the expression for this one. So 3, if you are having x, y, and z variables here, the 3 can be written as what? In binary, that is 0, 1, 1. It means x dash y z. Then 4 can be written as what? 1, 0, 0, x, y dash, z dash, and then x, y, and z. That will be the answer. If it's in A, B, C, and D, these 4 variables. Okay. If you go with 4 variables, A, B, C, and D. So 3 can be written as 0, 0, 1, 1. A dash, B dash, C, D. 4 can be written as what? 0, 1, 0, 0. A dash, B, C dash, D dash. Then 7 can be written as 0, 1, 1, 1. So that will be A bar, B, C, D. It will be depend on the answers. What was the answer? Right? Okay. The Laplace transform वाले में xt is a causal signal. इतना आसान कैसे दे सकते हैं वो सर? टीसीएस यार एग्जाम नहीं बनाता. टीसीएस जो है बेसिकली टीसीएस जो है केवल कंडक्ट कराता है एग्जाम को, राइट? एग्जाम बनाने वाली बॉडी अलग होती है. How is the shift in time domain dissipated in S domain? We already discussed this question yesterday, right? In the live session. If you attend that, you will know that if you are doing the time shift, x of t minus t naught or plus t naught, this is called time shift. And in S domain, that will be going to be S t naught plus and minus is also there. It will be right shift or left shift or right shift. It will depend on that thing, right? कट ऑफ अगर पेपर के लेवल को देखा जाए, जिस टाइप का कट ऑफ था, पेपर का लेवल था, तो आप मान सकते हैं 65 to 70 इज अ गुड स्कोर इन दैट वन. I already give the answer for that question, the 4-bit number here. That is A, B, C, D like this. That is shift. Question was why programmer prefer Mealy machine compared to Moore machine. See, Mealy machine generally prefer over Moore machine because Mealy machine has less number of states, one state less than the Moore machine to implement any circuit. That's why we generally prefer Mealy machine over Moore machine, right? EMT के क्वेश्चन भर भर के आए थे, राइट? बेसिकली BAL is more focused on what the the EMFT instruments, they are making that one. That's why less power required in Mire machine. That's not the option. There should be less number of state as compared to More machine. MK Bionic sir, see my question that system uses traffic signal for a Mealy finite state machine system. S0 green, S1 yellow, S2 red, right? Then X 0 no vehicle, 1 is vehicle. If Y is equals to 1, then what will be X? This is not complete question, Bionic. It should be having something else. It's not complete. So what was the output and what was everything is given there. Previous slide, the derivative of xt, where xt is a causal signal. So that derivative of xt, if you take previous slide, derivative, what was that? Derivative of xt, that is not derivative, it is integration of xt dt. You have to find its Laplace transform. अगर आपने सीरीज आरएलसी सर्किट है, ये बोल रहे सीरीज आरएलसी सर्किट है, आर नॉट आरएलसी, आरसी सर्किट है. वी हैव गिवन हियर एज ए वोल्टेज सोर्स एज ए impulse signal delta t, r and c. This is the question, right? Series RC circuit, the output voltage निकालना था when the input voltage. So where we have to find the output voltage? Across the capacitor or where? The output voltage is across the capacitor, right? Across the capacitor. So here we have to find the output voltage, V out T. See, basically you can do this thing in the S domain also. If I take this circuit in S domain, so this has become 1, this is R as it is, this is going to be 1 upon CS. And if you apply the voltage division rule, if you apply the voltage division rule here, so V out S is going to be how much? V out S, that is 1 upon CS divided by R plus 1 upon CS times the input voltage is 1 for us in S domain, right? So that means if I go for this one, the CS is cancel out, so 1 upon RCS plus 1. And if you take the inverse Laplace transform of this one, so you have to take RC common, and that is going to be 1 plus S upon 1 upon RC. So its value is going to be 1 upon RC, the V out T. This is in S domain, right? V out T, if you take the inverse Laplace transform, that is 1 upon RC e raised to the power minus T upon RC. That should be the answer for this question. Check. Right, Anurag? Yes. That's the correct answer for this question. So if you do the delta, okay, the same question, Anurag says that इसी के दूसरे question में delta t minus capital T कर दिया था input को. Okay, the same thing. He changed the input delta t minus capital T. Okay, if you do the delta t minus capital T, there is only one change, that will be e raised to the power minus st, and it will go here e raised to the power minus st, and that will change how much? Only this part, e raised to the power minus t minus 1, sorry, t minus capital T upon RC. That's the option. Nothing will change. Correct? There is only one change, that is minus t minus capital C. सो देखिए जैसे उसने क्या किया, अगर आप ध्यान से देखोगे इस पूरे पेपर को, अभी आपने ये क्वेश्चन बोला, पहले वाला क्वेश्चन बोला 1 नंबर का, तो उसी 1 नंबर के क्वेश्चन में आपको ज्यादा कैलकुलेशन करने की जरूरत नहीं है। हाँ, यूटी माइनस टी मल्टीप्लाई होगा, बट अगर उसने दिया होगा आपको यहाँ पे कंडीशन लिख के दी होगी तो यहाँ पे मल्टीप्लाई तो होगा, यूटी माइनस कैपिटल टी तो मल्टीप्लाई होगा, ऑब्वियस सी बात है। राइट उस्मान? So according to me, if I talk about yes, that was the option. That's correct. It should be here ut minus capital T. That should be the option. Right. If I go for the paper, according to me, paper is lengthy, not hard. Lengthy. If you choose the questions correctly, and if you solve them by an strategy, you can tackle that thing. Right. Okay. He says that T sync of ft, the bandwidth of main lobe. See, this is T sync of f capital T. This is the signal given to you. You have to calculate the bandwidth, main lobe bandwidth. So if I write this, this is T sine of pi ft by pi ft. So if I draw the graph of this one, the graph of this one is what? Because it is a sync function, that graph will look like this one. So basically the first time when they will be zero, when this sine term is going to be zero. So at not origin, because no origin it will have maximum value, the sine term will be zero first time when your inside function will have how much value? Sine is at 0, and then next time it will be 0 at pi. So it means pi f t is going to be pi. So pi cancel out, f should be equals to 1 upon t. So this is the value 1, it will be first time 1, that is 1 upon t. And here minus 1 upon t. If he is asking about the bandwidth, main lobe bandwidth, the bandwidth is going to be this one. Only 1 upon t, not 2 upon t. The main width, because always you have to calculate the bandwidth, that should be for positive frequency only. Not 2 upon t, right Sheikh? It is t 1 upon t, because for bandwidth we have to consider only positive frequency, no negative frequency for the bandwidth. Option is given f. How f will be the bandwidth? F is the frequency there. T will not be the bandwidth. That is 1 upon t. You can check it here. Right. Any other question? 2 by t. 2 by t is not correct. If this signal is band pass signal, means if I multiply this one cos of omega naught cos of omega ct, then its bandwidth, because it will be shifted at fc, then we have to count the main lobe, that is going to be how much? 2f 2 by t that time. डिप्लेशन और इन्वर्जन रीजन के ऊपर, डिप्लेशन और इन्वर्जन रीजन के ऊपर क्या क्वेश्चन था भाई? Answer will be 1 upon t, not 2 upon t. Right, MK? Usman, for a P substrate MOSFET, what is the condition for accumulation, depletion and inversion mode? So for the MOSFET, if you are having p substrate MOSFET, EDC में क्वेश्चन था वो सेमीकंडक्टर क्या होता है, क्या इंक्रीज करते हैं डिक्रीज करता है? नहीं भाई मेरे को समझ नहीं आया सौरभ आप क्या कहना चाहते हैं उस्माद. Unreserved cutoff is around 70. If you read the 70 question correctly, you will definitely have the chance to get that. मैच करना है राइट, ऐसे तो आइडिया नहीं लगेगा. एक और क्वेश्चन है मेरे पास, राइट, नोट डाउन दैट मैसेज सिग्नल फ्रीक्वेंसी FM इज गिवन टू यू, that is 5 kilohertz, and frequency deviation delta F is given to you 75 kilohertz. What is the modulation index beta and the bandwidth? I think modulation index or bandwidth he is asking. Check, is that correct question or something else he is asking? He is asking for bandwidth and modulation index or only bandwidth. Both, दोनों पूछे थे, right? So the beta value is how much? Delta F upon FM. The delta F is 75 by 5, so that is 15. 15. So beta value is going to be 15, right? Beta value is going to be 15. The bandwidth is going to be twice FM beta plus 1. That is going to be twice. FM is how much? That is 5 and that is 16. So 10, 60, 160 kilohertz is the bandwidth. Tyson, 74 is a very good attempt, right? That is very good attempt. If you did 74, that is very good attempt. Semiconductor at absolute zero. Semiconductor at absolute zero will behave as an insulator. Intrinsic semiconductor will behave as an insulator at T equals to 0. Right? As you increase the temperature, its conductivity is going to increase and has infinite resistivity. That's correct. Anurag, intrinsic semiconductor behave as an insulator at T equals to 0 and having infinite resistivity. That's the correct answer for that one, right? SC/HT का कट ऑफ तो बहुत कम जा सकता है भाई, 50 के अराउंड भी आप, अगर आप 50 मार्क्स का स्कोर कर रहे हो तो चांसेस रहेंगे आपका, राइट? 74 सर कट ऑफ क्या रहेगी? कट ऑफ 70 के आसपास ही रहने वाली है भाई. If the light is emitted on photodiode, then what happened to majority and minority carriers, right Usman? If light is fall on a photodiode, right, light is emitted on photodiode, what happened to majority carrier and minority carrier? Majority carrier concentration will not going to change, minority carrier concentration will going to change. Effect of light on charge carrier in photodiode, right? That's, if we are talking about majority carrier concentration will not going to be changed, only minority carrier concentration will change. And reverse current, फोटोडायोड में जब आप फोटोडायोड को यूज करते हो रिवर्स बायस में, रिवर्स करंट जो है अगर लाइट डालोगे तो बढ़ेगा. एप्टीट्यूड क्वेश्चंस वर टफ, मे बी, right? Any other question from your side? I have only these questions I already discussed with you. Any other questions from your side? न्यूमेरिकल थे, मैथ वाज लेंथी. हाँ जी, पेपर तभी थोड़ा डिफिकल्ट है, टफ माना जा रहा है. क्यों माना जा रहा है? बेसिकली क्योंकि लेंथी था, राइट? लेंथी था, कैलकुलेटिव था, फुल डेसिमल कैलकुलेशन इन एप्टीट्यूड, राइट? यस, टाइम टेकिंग था. देखो यार, अगर मैं इन सारे क्वेश्चंस को देखूं, सारे क्वेश्चंस को लगा के देखूं अभी तक जो मैंने किए, टफ नहीं बोल सकते आप इनको, लेंथी बोलोगे. टफ तो वो है यार जो मतलब बहुत मुश्किल आ जाए. कैलकुलेटिव ज्यादा था, और कैलकुलेटिव भी इसलिए ज्यादा डिफिकल्ट हो गया था क्योंकि कैलकुलेटर इज नॉट अलाउड देयर. रिवर्स करंट बढ़ेगा या घटेगा, किस में पूछ रहे हैं अनुराग आप, किसका रिवर्स करंट बढ़ेगा या घटेगा? कैलकुलेटिव भी मैं यही चीज आपको क्लियर कर दूं यार, कैलकुलेटिव भी इसलिए था, मतलब आप कह सकते हो लेंथ इसलिए था, कैलकुलेटर अलाउड नहीं था, राइट? अगर आपके पास कैलकुलेटर अलाउड होता तो मैं इसको डिफिकल्ट एग्जाम की कैटेगरी में नहीं रखूंगा, तब ये मीडियम लेवल पे आ जाएगा। अगर कैलकुलेटर नहीं है तब ये डिफिकल्ट है भाई, कैलकुलेशन कॉम्प्लिकेटेड हो जाती थी। हाँ, मेन वही चीज है। वेवलेंथ was used to calculate if frequency was 10 terahertz। सर एलईडी की वेवलेंथ पूछ रहा था जब फ्रीक्वेंसी वो 4 टेराहर्ट्ज है, कोई 10 टेराहर्ट्ज लिख रहा है, कोई 4 टेराहर्ट्ज लिख रहा है। ओके, रेक्टेंगुलर वेवगाइड के अंदर ए दिया हुआ था ऑपरेटिंग फ्रीक्वेंसी ऑफ वेवगाइड, उसके बाद इट इज नॉट करेक्ट। इफ यू रेक्टेंगुलर वेवगाइड देयर शुड बी टू डायमेंशन ए एंड बी। The cutoff frequency formula for the rectangular waveguide is fc is going to be vp by 2 under root of m by a whole square n by b whole square. I think he's asking for the minimum cutoff frequency. Minimum cutoff frequency. So if it is a, that is going to be 3 into 10 raised to power 4 or 10 raised to power 8 divided by 2 and into a. A is how much? That is 3 centimeter. 3 centimeter means 3 into 10 raised to power minus 2. So this will cancel out. It goes to there. So 10 by 2 into 10 raised to power 9. That is going to be 5 gigahertz. That should be the cutoff frequency for that one. T1 mode, right? 79 क्वेश्चन किए हैं, 80% एक्यूरेसी चांस है भाई आपके। ब्रिविस्ट एंगल वाज आस्क्ड फॉर व्हेन द मीडियम चेंज फ्रॉम mu1 to 3, mu is going to from 1 to 3 and angle of incidence is 60 degree। ब्रिविस्टर एंगल ऑफ इंसिडेंस पे तो डिपेंड नहीं करता, क्वेश्चन कंप्लीट नहीं है, कुछ और क्वेश्चन होगा। Okay, sir, I attempt 79 with accurate 80% accuracy. That's the good questions attempts if you are attempting 80 questions. In technical or you are talking about overall, bionic? LCM तो aptitude वाला part था ये आपके पास, right? So if you have any question you can put that। angle of arrival पूछ रहा था for a transfer function। हाँ जी, अगर angle of arrival पूछ रहा है that is very difficult to calculate if calculation are difficult for that one। angle of arrival of 0 at x equals to -1। Himanshu, angle of arrival at 0, that should be the that pole and zeros are given to you, then only you can calculate that thing, angle of arrival and angle of departure for that one, right? 2 पोल 1 0 का एंगल ऑफ अराइवल ऐसे नहीं पता चलता भाई, एंगल ऑफ अराइवल और एंगल ऑफ डिपार्चर के लिए आपको वो पोल और जीरो की एग्जैक्ट लोकेशन पता होनी चाहिए, फिर किस पोल पे आपने निकालना है, किस जीरो पे निकालना है, उसकी लोकेशन पता होनी चाहिए, तभी आप कर पाओगे। ऐसे हवा में नहीं कर पाएंगे ना कि 2 पोल और 1 जीरो के साथ। ठीक है, और कोई क्वेश्चन है किसी का? मैं यही कंक्लूड करूंगा भाई, पेपर जो है वो कैलकुलेटिव ज्यादा था। ठीक है, जिसको लग रहा बहुत हार्ड था, बहुत हार्ड कैटेगरी में आप नहीं रखोगे, कैलकुलेटिव रखोगे। अगर आपके पास कैलकुलेटर अलाउड था तो आप 2 आवर्स में मोर देन इनफ था, राइट? मोर देन इनफ था, तब आप इसको कंप्लीट कर सकते थे, अदरवाइज इट्स लेंथी फॉर यू। ओके, z+2 डिवाइडेड बाय z+1 z+3, राइट? पेपर वाज वेरी वेरी टफ। हाँ, कैलकुलेटिव कहोगे यार, ठीक है। What is the nature of polarization at Brewster angle? What is the polarization nature means? What are the options according to that? What I can tell you that? नहीं, मैं मायूस नहीं हूं भाई, मुझे पता है जिसने अच्छे से प्रिपरेशन करी होगी, ठीक है, कट ऑफ उसी हिसाब से अजय कुमार नीचे जाएगी। हाँ मुझे पता है यार, मोस्टली क्योंकि मैंने जो सेशन लिया था, लास्ट लास्ट सेशन लिया था, और उससे पहले ईएमएफटी और कम्युनिकेशन का एक सेशन लिया था आपके साथ, राइट। मैंने उसमें ज्यादातर न्यूमेरिकल पोर्शन डाला था, क्योंकि लास्ट टू टाइम से क्या हो रहा था अपने पास, वो लोग ज्यादातर थ्योरेटिकल पार्ट डाल रहे थे, तो हर जगह थ्योरेटिकल क्वेश्चन इतने पॉसिबल है ही नहीं, तो इस बार उन्होंने कैलकुलेटिव पार्ट डालना था। अगर आप हमारा मॉड्यूल भी उठा के देखोगे, राइट, जिसने क्लासेस लगाई हैं ऑनलाइन, राइट, जिसने क्लासेस लगाई हैं ऑनलाइन वो जाके चेक कर सकता है। हमने मोस्टली फोकस जो किया था थ्योरी एज वेल एज न्यूमेरिकल, सारी चीजें हमने सब डिस्कस किया हुआ है। आप एक एक चीज उठा के देख सकते हो, जाके सारी चीजें डिस्कस की हैं, हर एक फॉर्मूला, हर एक चीज, हर एक फॉर्मूला, हर एक चीज हमने डिस्कस की है। हाँ वो देखना पड़ेगा, टाइसन की क्या ऑप्शन दिए हुए थे, उसी के अकॉर्डिंग आंसर दिया जा सकता है। जंक्शन कैपेसिटेंस डिपेंड्स ऑन व्हाट, जंक्शन कैपेसिटेंस किस पे डिपेंड करता है? दो तरह के जंक्शन कैपेसिटेंस होते हैं भाई, डायोड की बात ही कर रहे होंगे ना आप। दो तरह के, एक फॉरवर्ड बायस में, एक रिवर्स बायस में। कट ऑफ, कट ऑफ के चांसेस यही रहेंगे अगर आपने 60 to 70 अटेम्प्ट किए हैं, राइट, और आपके 95-90% एक्यूरेसी है, तो आपके चांसेस रहेंगे। डिले टाइम डिपेंड ऑन सेकेंड ऑर्डर, जीटा, ओमेगा और बोथ। तो आप डायरेक्टली डिले टाइम का फॉर्मूला देख सकते हो, एड बी, मूव बी, एल एक्स आई, एम वी आई, कुछ ऐसा प्रोग्राम दिया होगा, राइट। नो सर, कैलकुलेटर अलाउड, नो कैलकुलेटर इज अलाउड देयर, राइट, दैट्स व्हाई इट्स लेंथी। ओके चलो कंक्लूड करते हैं इसको यहीं पे, राइट। सो मोस्टली यही कहेंगे कि भाई पेपर जो है लेंथी था, तो इसमें आपने होप नहीं छोड़नी। अगर आपने अटेम्प्ट किए हैं तो सबके लिए लेंथी है। दिस पेपर इज लेंथी फॉर एवरीवन, नॉट ओनली फॉर यू, राइट, दिस इज फॉर एवरीवन। And you are having very good chance if you are do the 65 to 70 questions. We are having a very good chance for that one. You are having a very good chance for the call for interview, right? Okay. नहीं घबराना नहीं है अजय कुमार, राइट। इंटरव्यू के लिए मेनली यार, इंटरव्यू की प्रिपरेशन डिफरेंट होती है। उसके लिए जब इंटरव्यू की शॉर्ट लिस्टिंग आ जाएगी, उससे पहले भी मैं कुछ वीडियोस डालूंगा कैसे आपने इसकी प्रिपरेशन स्टार्ट करनी है, किन सब्जेक्ट्स पे फोकस करना है। बिकॉज इन बीएल वी आर मोस्टली फोकसिंग ऑन रडार पार्ट, most of the question they ask from the radar, and we will also provide you the interaction of the students which give the interview last year, which type of questions are there. You can continuously watching the YourPedia and you will get definitely for that interview, right? या इंटरव्यू के लिए टाइम मिलेगा, यस टाइम मिलेगा। अभी से भी आप प्रिपरेशन स्टार्ट कर सकते हैं। योरपीडिया चैनल पे जाके देखो, बीएल के लास्ट ईयर के इंटरव्यू जो हुए हैं उनके हमने इंटरेक्शन स्टूडेंट्स के साथ डाले हैं, किस टाइप के क्वेश्चन पूछे हैं, तो वहां से आप अपनी प्रिपरेशन को भी स्टार्ट कर सकते हैं। They are mostly focusing, I'm again saying, they are mostly focusing on radar part, right? The radar is most important, communication is most important, EMFT is most important. देखते हैं, अभी तो यार पहले इनकी सीट वो आएगी, क्या बोलते हैं, फिर 25 को आई थिंक दे विल प्रोवाइड यू द आंसर शीट्स, एंड right, and after that we will discuss that when will we expecting, in within 1 month, within 1 or 2 months we will expect for the final result and interview calls for from this BL, right? Okay. Okay then, bye bye and best of luck.